Let's break down 4 powerful optimization techniques used in artificial intelligence, which are direct preference optimization, Kahneman-Tversky optimization, reinforcement learning from human feedback, and supervised learning. So today we will explain them in a simple, relatable term so that anyone can understand their concepts. So let's start with direct preference optimization. So what is direct preference optimization? So basically this direct preference optimization is a technique used in machine learning to train models more efficiently. So it's like a shortcut for finding the best solution, allowing models to learn faster and perform better. So imagine you are a chef trying to create the perfect recipe for a dish, and you have a long list of ingredients and cooking techniques to choose from. Now this direct preference optimization helps you find the best combination of ingredients and text by asking you to rate your preferences. So let us say you are making a chocolate cake and you are asked to rank your preference for various ingredients like cocoa powder, sugar, eggs and vanilla extract. And based on your preferences, this direct preference optimization will create a personalized recipe that maximizes the fact that you value most. And this way you can be sure your cake will turn out delicious, tailored to your specific taste. So in AI, this direct preference optimization works similarly. It optimizes the model performance by tweaking the parameters that matter the most to you. And by providing the preferences, you can guide the model towards a solution that best fits your need. Next comes this Kahneman-Tversky optimization. Well, this Kahneman-Tversky optimization, also known as prospect theory, is a decision-making model that takes into account how people actually make choices in real life rather than assuming that they act rationally. And it helps explain why people tend to make decisions differently when faced with gain versus loss. So think of it as a game of gains and losses. So imagine you are offered two choices: a 50% chance to win $100 or a 50% chance to lose $50. And in the second choice, you have 50% chance to win $75 or a 50% chance to lose $75. So according to this Kahneman-Tversky optimization or the prospect theory, most people would choose the first option. That is 50% chance to win $100, 50% chance to lose $50. Even though both choices have the same expected value of $25. This is because we tend to be more sensitive to losses than to gains. And the possibility of losing $50 is perceived as riskier than the possibility of gaining $25. So in AI, this Kahneman-Tversky optimization helps you design better algorithms by considering how people actually make decisions in real life. So by taking into account our inherent biases and preference, you can create models that reflect human behavior and make accurate predictions. Next comes this reinforcement learning from human feedback. Well, this reinforcement learning from human feedback is a technique used to train AI models by incorporating feedback from human experts. So it's like having a mentor guide you through a challenging task to help you improve your performance. So imagine you are learning to play a new video game and you start playing, making mistakes and receiving feedback from a seasoned player. They guide you on the best moves to make, help you avoid pitfalls and suggest strategies to improve your gameplay. And over time, you learn from their expertise and become a better player. So in AI, this reinforcement learning from human feedback works similarly. The AI model is presented with a task and human experts provide feedback on the quality of model's output. And this AI learns from this feedback, making adjustment to its decision and improving its performance. For example, consider a language model designed to generate human-like responses. Now this AI will generate text and the human evaluators assess its quality. Then the AI is then updated based on the feedback it receives, learning to produce more accurate and coherent responses. So by incorporating this human feedback, the model's performance is significantly improved, making it a more reliable and helpful tool. Next comes the supervised learning. Well, the supervised learning is a type of machine learning where the model learns to make predictions by analyzing the label training data. So it's like a teacher who helps a student learn by providing answers to the question. So imagine you are a new employee at a customer service center and your task is to classify customer emails into categories like technical support, billing inquiries and sales. And your supervisor, that is the teacher, provides you with a set of sampled email labels where each email is categorized into its respective group. And you study that label data, start to recognize patterns and characteristics associated with each category. So in supervised learning, the machine learning model is your employee. And the label training data is a set of customer emails with their respective categories. And this model learns to recognize patterns and make prediction based on this labeled example. So once the model is trained, it can be used to classify new unlabeled customer emails into their appropriate categories without human intervention. And this process of making prediction on new data is called inference. Supervised learning is widely used in various applications such as image recognition, spam filtering, and speech recognition. Thank you.